Okay, so last day we did some graphing, just of sine and cos functions. We'll do the tangent functions at the end or in the next section. So just knowing what you know about transformations, what we've done in the last few chapters with either square root functions or absolute value or even just our quadratic functions, the same rules will apply when we're looking at trig functions and applying transformations to them. So this should actually say section 5.2, transformations of sinusoidal functions, basically just transformations of sine functions. And it's not, when they say sinusoidal, that covers both sine and cos. So I'm just going to put transformations. So it says, use your knowledge of transformations. What is the difference between y is equal to cos x and y is equal to cos x plus 2? So if you think of this as just being our y is equal to ax plus b, or if you're thinking in terms of our y is equal to a times absolute value x b, this still means the same thing. This still means that you are going to shift this up 2. It's outside your bracket, it's not inside with the x, so we know that that means it's going to be affecting the y value. So that means y is equal to cos x minus 3. You shift your function down 3. Now remember with cos functions from last day, cos functions always start here and then they go down and then they come back up. So if this is 1, this point here would be minus 1. So that's a regular cos function, or a normal cos function if you want to call it that. So vertical translations, when we're dealing with trig functions, are actually what they refer to them in your book are called vertical displacements, and you're displacing it from the center line. So it's vertical displacements from that center line. And so vertical means that you're going up or down. So knowing that that's what adding it to the outside of the function is going to do, what's going to happen then if we add it inside? So if we use y is equal to sine x as our base function, y is equal to sine x plus 2 then means you're going to have that same thing as we did with other functions. It's a horizontal shift. It's a plus 2, so same rules apply. You take the opposite sign, so that means this one is going to go left 2 spaces. So this function here, sine function, normally starts like this and ends up like this. This one here, because it's going left 2 instead of starting at 0, it'll start here at negative 2. And it'll do, whoops, it'll have the same curve, but it'll be over 2 spots. This should have ended there. Y is equal to sine x minus pi means that you're going to move to the right pi. Y is equal to sine 3x minus 9 pi. This is where you have to be careful. Remember, the x has to have that bracket in between it and the value. So that means that you have to GCF this 3 out of here. So this is actually proper, where it would be 3 times x minus 3 pi. So this now becomes the b value outside there, the function. So that means for this one, you have, because of our b there, we have a horizontal shift factor. You remember that from our last units, of 1/3, because it's 1 over b, and it's going to go to the right 3 pi, or horizontal stretch factor, not shift. So that means that it's this one will actually be compressing it. It'll be shrinking it a little bit. So we call horizontal translations, instead of horizontal translations when we're dealing with trig functions, we call them phase shifts. and the phase shifts go left or right. Okay, so when we're looking at these transformations on our sinusoidal functions, there's a couple of steps that you need to do, and there's an order you need to do them in. So it says to account for these differences, you should start your trig graphs by plotting your center line. So that's going to be your vertical displacement. That's going to be your up or down. So we want to do that first. Okay, so we plot a vertical displacement before on a normal graph, both cos and sine. It started at, if it was here, this point here is y is equal to 0. So now if we had a vertical displacement of a positive 2, we take a dotted line and we draw it so that it's 2 up. And then once you do that, you're going to plot your starting line, which is your phase shift. So we draw a new center line first, and then we draw our starting line, which means basically we're moving that vertical axis. So first you're going to move your horizontal axis, and then you're going to move your vertical axis. So take, for example, in this second one here, we're moving right pi. So instead of starting here, if I were to mark these off at pi, 2 pi, and then of course in between there we'd have pi over 4, pi over 2, 3 pi over 2. That means that my new starting line, instead of starting here at 0, it's going to start here. So my sine, if this was a sine graph that I was doing, would normally have been going like this. Okay, well actually it should go to 2 pi. We'll just pretend it had a compression in there. Now it's going to go like this. Oops, sorry, I started that wrong. This is like, this point right here is now like my 0, 0 was here. So it's going to go like this. Okay? So let's try that. And this is where when you're doing these, having colored pencils or like pencil crayons or pens, if you are sure you're not going to make too many mistakes, is a really good idea, especially for putting in that new center line and that new starting line. Okay, so y is equal to sine x plus pi minus 1. So if I take a look at this one, my vertical displacement is a negative 1. So that means I'm going to go down 1. My phase shift is in here. It's a plus pi, so that means I have to go to the left pi. Okay, so I'm going to put in my new center line and my new starting line. So vertical displacement goes down negative 1. So negative 1 is going to put me here. And then my phase shift is to the left pi. So instead of starting at 0, it's going to start here at pi. At negative pi. So then I can look at all my other factors. Okay, my amplitude, or is equal to 1. I'm not multiplying anything in front of there, so it's a 1. My b value, which would be inside here, b is equal to 1. So that means that my period is 2 pi over b, so it's going to be 2 pi over 1, so it's just 2 pi. And then the next thing that I figured out was my key points. And my key points, I take whatever the period is divided by 4. So key points are my period. So this is period divided by 4. So 2 pi divided by 4, so every pi over 2, I have to put in my key points. Okay, so now I can start drawing my picture. This is a sine graph, so I know I start at 0, and then I go up to 1. Since my amplitude is a 1, it's just going 1, and I have to be finished my up, down, and then back up again by the time I have covered the distance of 2 pi, or a period of 2 pi. So key points. So if I'm starting from, and I'll put this in color here and then I'll get rid of it. So from here to here, that's going to be 1 pi, and then from here to here is my other pi. So my whole graph is going to start here and end here. So this is going to be my one key point, and then I have to divide it. Every pi over 2 is going to be where another key point is. So I have a key point there. Where am I? Pi over 2, here, here, and then that would be where I'm starting. So you can see I've evenly divided from this new point here to my pi over here, which is a distance of 2 pi, which works for my period. I have evenly divided that into 4 regions, or 4 sections. So now I can plot this. I know from my previous work in the last one, or from the unit circle, it always comes back to the unit circle, that my graph goes, first it's a 0 at the beginning, and then halfway through, and then at the end again. And in between there then, it goes up 1 because of my amplitude of 1, and then down 1 when I get to the other one. So up 1 from here, if this is 0, and these are being marked off in, every second one is a value. So I go to there, this is going to be back here, so I go down 1. So my graph will look like that. Okay, now I just drew this for 1 period. I could extend it for 2 periods or 3 periods. I don't have enough graph paper on here to do more than that. But if I were to extend it, then it would just be going like this. This should be right on that dot, right on the edge there. Excuse me, I had to sneeze. And then going this way, I would have my other points would be back here, so it would look like that. Okay? But if I only need to show it for 1 period, then that's all I need to show. It's just the solid blue line there. Okay, so the next one says y is equal to cos x minus pi over 2 plus 1. So it's a cos graph, so I know cos graphs, when they are normal, start up at 1, go down to 1, and then go back up like that. So I have to remember those key values when I'm looking at plotting this. Okay, where is it equal to 0, and where is it equal to that 1, or where am I going 1 up? So if I look at the information from there, y is equal to cos x minus pi over 2. So my vertical displacement, and I'm just going to shorten that, is a plus 1, so I'm going up 1. My phase shift it's a pi minus 2, negative pi over 2, so I'm going right pi over 2. And then if I look at my amplitude, so my A value is just equal to 1, so it's just going to be that normal 1 above, 1 unit above, 1 unit below. Excuse me, my B value is equal to 1, which means that my period is going to be 2 pi. So in 2 pi, I have to do that kind of funny looking U, if you want to call it. My key points then, 2 pi divided by 4, so that's every pi over 2, I have to have a key point. Okay, so number 1, I start with my my vertical displacement and my phase shift. I'll pick a different color for that one. Let's do this kind of limey looking green. Okay, so if I'm going up 1, so normally I start here, but now my new one is going to go up 1, so that's going to be here. Oh, I want to dotted line that one. It's not very thick, but that's okay. And now my phase shift was right pi over 2. So if this is pi, this value here would be pi over 2, halfway in between. So then that means that's where it's going to start. So I need to do a total of 2 pi, cover a distance of 2 pi, in order for my graph to be complete. So in this little bit here from my new, let's see if I can make my line a little thicker. No, it's not going to let me. Okay. From my new starting point here, because my amplitude is 1 and my B value there is also a 1, I'm not switching it. I'm not going up to, right? I'm only sticking with that normal curve of 1. So every pi over 2, I need to have a key point. So if this is where I'm starting, my key points are going to be here. So there's 1 from pi over 2 to pi, then another one would be there, and another one would be there. But that's not giving me 4 sections, so I actually have to go this way. Oops. Sorry. So from here to here, and I'll put these lines in here. So from here to here will be 1 section, 2, 3, 4. So that's where my 4 key sections are for doing my, where each of these changes will be at. If this was my normal here, so I'd have 1 here, 1 here, 1 here, and 1 here. So I need to have those 4 regions in order to do that in. Okay, so I know what at my starting one here, I'm supposed to be up 1. So that's where I can put one of my key points. Whoops. Before I do that, I'm just going to get rid of those 4 lines right there. Or not. There we go. There. Okay. So my starting value is, this is my new origin right here. And at the origin or the start, I'm up here 1. And then I go down to 0. And then I go down -1. And then it goes back up to 0. So those are just from the key points on my graph, where I have to, for a cos, I start at 1, go to 0, go below 1, and then back up to 0. But like I said, I haven't done a full cycle on this because I've only got, I would only have an up, down, so I have to go back to my start. So that means this one, I need this value right here. So my graph would look like this. Oops, pretend the curves are nice. Like that. So that would show me 1 full cycle. That covers a distance of 2 pi. And if I wanted to extend it, so this here, 1 period would go from here to here. And the reason why, and one of the things that you're looking for 1 period is you have to have 3 zeros within that 1 period. If I look at my sine graph here, I've got 1, 2, 3 periods, or 3 zeros within what I consider to be a period. Same thing with the cos graph. I have to have that going back to my 0 or my center line 3 times. So I went here, here, and there. Now I could continue this graph the other way. So all that would mean, though, is that every pi over 2, I would have to fill in my key point. So if I went 0 here, I'd be down to -1, back to 0, up 1, and then down to 1 again. So my other side of this graph would look like that. So it depends on what the question says. If it only says for one period, or sometimes you're going to come across ones where they'll have restrictions between negative pi and 2 pi or whatever. So if this question said to draw the graph between negative pi and 2 pi, then that would look like this. I would have to include that, okay, if that were my restrictions for it. So it just depends on what the restriction says. If there's nothing there, then you assume you do it for one period. Okay, so now it says let's try putting the pieces together. So now we're going to add in our amplitude and our B value, which is going to affect our phase shift, and also it's going to affect our key points as to where we're going to put them in the period. So if I look at this, my A value is equal to 2, my B value is equal to 1/2. Inside here, your H is a pi, and your K is a -1. So that means then, when I look at this, my vertical displacement was a -1, so I'm going to go down 1. My phase shift is that H value, and it's a pi, so I'm going right pi. My amplitude, or my A value, is equal to 2. So that means that in starting, this is a sine graph, so or cos graph, instead of starting at 1, I multiply that by 2. 1 times 2 is 2, so I have to start at 2. And then my B was equal to 1/2. So that means that my period is equal to 2 pi divided by 1/2, which is just 2 pi times 2, so it's a 4 pi. So that means that this graph has to cover a distance of 4 pi by the time I've done my 3 zeros and my up and my down. Key points then, I'm just going to slide this way a little bit. My key points are always my period divided by 4. So that means that those up, down, and my 3 zeros are going to happen every pi for this graph. Okay, so number 1 I start with is putting in that vertical displacement and my phase shift. So vertical displacement says I'm going down 1. So this is my new center line. Phase shift says I'm going right pi. So this is my new origin starting. Okay. My key points say that every pi I have to have a key point. So that means there will be 1, 2, 3. That's where I would start. So that means I have to go right to here in order to do one full phase shift. If I'm filling in my complete graph here, then I would just keep putting, my key points would happen, we said, every pi. Okay, so I'm doing a cos graph. Cos has to start, a normal graph starts at 0, or sorry, at 1, but because I have that amplitude of 2, then that means, and I put this on my center line, I actually should have put these here. Okay, so normally I would start here at, which would be 1 up, but because this is an amplitude of 2, that means I'm going to start at 2 right here. I'm going to change my color there so you can see it a bit better. So then that means that my next key point, if I started up, then I have to go to my 0, so my center line, and now I have to go below, and that means I have to go 2 below, so that's going to put me right here. And then my next key point puts me back at 0. Okay, but I haven't finished a full cycle. So that means that I need to go, and in order to cover one full period, which I need to do over 4 pi, I have to go back this way. So if I was up here, if I started up, that means I have to go back to 0. And then I could continue. So this is going to give me my one period, and even though it looks like a sine graph, it's with the phase shift and everything else that's on there, the phase shift and the vertical displacement, it is a cos graph because of where my origin, right there, shows me that I'm starting up above it. I'm not starting right at the origin. So I could continue the other direction. This gives me one period from here to here, and you can check. So I've gone, here's 1 pi, 2 pi, 3 pi, 4 pi. So I've covered the distance of that 4 pi in order to get my period in there. And then I can continue the graph for the whole amount. So if I was at 0 here at the next key point, I have to go down my amplitude of 2. Then at the next key point, I'm back at 0. At the next one, I'm up 2 above it. And then where this graph ends, I'm back at 0. So this would be the continuation of the whole graph. The solid line is one period, so this, in essence, is actually 2 full periods of this cos function. Okay, y is equal to 4 sine 2x plus pi. Okay, again, this 2 inside my bracket there is right beside that x. I have to have a bracket in between there. So that means that this one, written properly, is actually y is equal to 4 sine 2x plus pi over 2, whoops, minus 2. So when I GCF a 2, if I divide by 2 here and 2 there, that's what pulls out the 2 in front. So these two cancel, leave me with an x. That stays as pi over 2. So that means in this one, my a is a 4, so my amplitude is going to be going, when it normally went up by 1, and I'm going to go 1 times 4, so it's going to go 4 times up. My b value there is a 2, so that means that that's going to affect my period and my key points. My h is a positive pi over 2, so that means it's a minus pi over 2, and my k is equal to negative 2. So when I put that all together here, my vertical displacement, that's the k value there, so that means I'm going down 2. My phase shift was a negative pi over 2, so that means I'm going left. Too many lines. Left pi over 2. My amplitude is a 4. So that means that when I start, it's going to start up at 4. Because it's a sine graph, I always start at the 0 going this way. But that means this point here will now be at a 4 instead of at 1. So my up, down, when I do those, is going to be that plus or minus 4. So my b value was equal to 2. So that means my period is equal to 2 pi over 2. So that means it's pi. So this whole graph between will have gone its up and down 3 zeros within a pi instead of what normally is 2 pi. So then that also means that my key points are going to be different. My key points are going to be that whatever the period is, divide by 4. So every pi over 4 is where I'm going to have my 0, my up 4, my 0, my down 4, and then my 0 again. Okay, so if I do first do my vertical shift, or vertical displacement and phase shift, down 2, So instead of being at the 0 there, it's going to be there. Phase shift left, pi over 2. So this is negative 0.5, so that's a half pi. So pi over 2 left will be right here. Am I supposed to go left? No, it was a negative, so it's going to be... I have the wrong... Did I write that wrong there? No? Oh, I'm okay. I'm looking at the next question. Okay, so now I can start my zeros and my ups and downs. Let me do this one in green. So, sine graph says I start at 0. So this is, oh, I need to mark my key point. So every pi over 4. So every 4 lines is giving me a half pi. So that means pi over 2 is where, so if this is 0, pi over 2, pi over 2, pi over 2. Okay, and I can go the other way, so it'd be there, 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 and there. So within 4 of these sections, so that's going to be between here and here, I will have completed 1 period. So I will have done my 0 up, 0 down, back to 0 again. So here's my origin. That's where I start at 0. And now my amplitude of 4, so I have to go up 4. And on this graph here, each one of these lines represents a value, so, or a unit. So 1, 2, 3, 4. Oops, I need to do that one here. So that's going to go up there. And then my next key point, I'm back at 0. And then the next key point, which is here, I'm going to be down 4. So 1, 2, 3, 4. And then back to 0. So you can see then, within 1 pi, I've done a full cycle. So I could continue on from here with my ups, downs, and my zeros. So it would continue here. This point would go down, 0, and then back up. So that would be a continuation of it. The solid is what 1 cycle would look like, and then if you continued the graph, that's what it would look. How it would continue. Okay, so that just deals with when we don't have any negatives in there, and we're worrying about reflections, whether a vertical or a horizontal reflection. So that's what this next part here does. So if my graph or my equation says y is equal to sine negative 1/2 x plus pi minus 1. So do the exact same thing. What's your a, b, h, k, and then what does that tell you? What do you have to do? So my a out here is just equal to 1. My b is a negative 1/2. My c, not my c, getting carried away with my alphabet. My h was that positive pi, so that means it's going to be negative pi, and my k value was a negative 1. So what does that mean? It means I have a vertical displacement. I'm going down 1. It means I have a phase shift, left pi. My amplitude is just 1, so that's going to be normal. My b value, whoops, not p value, is a negative 1/2. So let's just look at what that does to the period first. So my period is always 2 pi divided by the absolute value of b. Whoops, so let's pretend that says a negative 1/2 there. So that's the same thing as saying 2 pi times 2. So that's going to be 4 pi. We don't care because it's a distance. We don't care about that negative value in there. So then that means your key points are going to be 4 pi over 4. So this all happens within 4 pi. Every pi is where we're going to have our up, downs, and our 3 zeros. We have that negative value though. So because it's negative, it's going to reflect it in the y-axis. So because b is negative, we have a reflection in the y-axis. Okay, so that means we stick a mirror in that y, and it just reflects over onto the other side of the graph. So what I'm going to do for this one is I'm going to draw what the normal graph for this equation would have looked like if it was just this. So if our graph, and I'll do all the phase shifts and everything, but if this graph had just said y is equal to sine 1/2 x plus pi minus 1. So I'm going to draw both of those so that you can see what the reflection did. Okay, so step number 1, my vertical displacement, I'm going down 1. My phase shift is left pi. My key points are every pi. I have to complete this within 4 pi. One cycle has to be within 4 pi. Let me just do purple for my key point. So every pi, I have to have a key point. So that means here, 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 and here. And if I'm going the other direction, it would be there. Okay. So my normal graph for this, with those transformations on there, except for the negative, means that I would have went from 0, I start because it's a sine, so it starts at 0, and then it goes up 1, back to 0, down 1, back to 0. So if I look at this, I've covered 1 pi, 2 pi, 3 pi, 4 pi. So this is what this would have looked like without the reflection. With the reflection then, that means that each one of these, where it was on the left side here, is going to have to on the right side is going to have to reflect on the left. So my 0, 0 is going to stay. This one here, though, which was at the first key point was up, means it's going to be up on this key point. This point here, then, is going to reflect right on our new center line, or our displaced center line. The next one was down, so that means this one has to go down. And then the last one was back up, so it would go back up like that. So the reflected graph has to start here at my origin, so I'm going from here, here, and then back to there. But you notice, well, I went a little goofy on my curve there, but you'll notice that I haven't, oh, you know what, I'm sorry, I put this dot in the wrong spot. That's why my curve looks goofy, because that should have been back there. So I've only gone to here, so I haven't completed a cycle just because of this displacement that I've done. So that means that I have to continue it on this side. So to get one full period of 4 pi, because in here I've only covered 1, 2, 3, that means I have to do my next one. So if I was up, I'd gone up 0, so that means I'd have to go down. So that would be one full cycle of this function with the reflection. If I wanted to continue it, then I would just continue with my key point. So I'd have a key point there, there, and there. So it would continue and would look like that. So this from here to here gave me one period. I'm having problems with my P's and B's today. That would be a continuation of it. Okay, so now for my next graph here, I need to do my cos. This one, though, the reflection is in front. Okay, the reflection is on the A value, so that means that it's going to be a horizontal flip. So we did a vertical. Now this one, because it's the A, it means it's going to flip it down, so it's a horizontal flip. So same thing identify what values you have. A is -4, B is equal to, okay, that's inside there, so that means that this equation is actually, whoops, forgot about my cos. 2 times x minus pi over 2 minus 1. So my b value is equal to 2, h is a pi over 2, and k is a -1. So altogether, that means my vertical displacement is, whoops, down 1. My phase shift is right pi over 2. My amplitude was equal to a -4, so that means that I have to start 4 down instead of starting at my, this is a cos graph, so instead of starting at 1, it's starting at 4. And my b value was equal to pi over 2. So period then is equal to 2 pi. Oh, sorry, not my b. My b is just equal to 2. 2 pi divided by 2, so it's in pi. So your key points are every pi over 4. Okay, so that means because this is negative here, we're going to have that horizontal flip. And again, I'm going to draw you what would be the graph without that negative in there. So y is equal to 4 cos 2 x minus pi over 2 minus 1. So I'm going to draw the positive of that first, and then I'm going to draw what would it look like with that negative a value in there. So again, you start with your vertical displacement and phase shift. So my vertical displacement says I have to go down 1. So that puts me here. My phase shift says I'm going right pi over 2. So I'm going here. Okay, so now I do my normal graph. My normal graph, got to find all my values here. So this is a 4, so instead of starting at my 0 here, I'm going to start at 4, and is it every one of these is 1? Yeah. So I go, oh, first I'm going to put my key points in. Sorry, I forgot about that. So every pi over 4, I have a key point. Did I not go over far enough for my phase shift? Yeah, sorry. This line here needed to be over. At pi over 2. I did it at pi over 4. Okay, there now that makes more sense. So, normal graph for this, when I say normal, I mean the original graph without the flip. So I would have been up here, 1, 2, 3, 4. And then every pi over 2 is where I would have my key points, right? I gotta make sure I'm counting by 2s here. Okay. So normal would be there, and then I'd be back at 0, and then down 1, 2, 3, 4. But that's not going to give me a full cycle. So I have to go the other way and finish it off. So I'd be back to 0, and then this key point would be down. Down 4, not to -4, but down 4 from there. Okay, and then how many have I covered? 1, 2, 3, 4. Okay, so now I could draw, this would be my normal. And if I continued it, it'd be here. And 1, 2, 3. Did I do it again there? Nope. Alright, okay, I did okay. Okay, so that's what that would look like at y is equal to 4 cos x. So now what I'm going to do is the reflection of that. So all of the points that were below the line are now going to be above the line. My zeros will still stay the same, but it's those these y ones which are going to move or switch spots. So if this one was down here at -4 or 4 below the line, that means it has to be 4 above. So 1, 2, 3, 4, 0, and then 1, 2, 3, 4, back to 0, and then 1, 2, 3, 4, 0, 4, 0, and then 4. So my graph would go like that. So the green graph is this equation here. Okay? 1 period's worth would be, you could mark it in different spots, but basically 1 period worth, so that's where I had to kind of go a distance of 4 key points. So this would be 1, 2, 3, 4. So from here to here would be 1 period. Okay, and the last little part here is, what if you're given the graph and then you want to find out what is the equation for it? And you can do it for a cos. Each one of these, when you're given a graph, depending on what you call your phase shift and your vertical displacement, this graph, first graph will have a sine and cos function, and so will this second graph will have a sine and cos function. So sometimes the question will just say, write an equation for this function. Sometimes it'll tell you like this does, write a sine and a cos function for this. Okay, so the first thing you want to do then is you want to take a look at this and say, where would my center line be? So where am I going to be able to cut this graph perfectly in half? So what you do is you take a look at your highest point, sorry, that one, your highest point, which is up here, and same thing on the other side, and your lowest point. So that means that this has traveled a distance of, every one of these is, we're 0. So here's 2, this one's 4, so it's 5. And I guess every one of these is 2, so that's actually going to be up there at 6, right? This is 2. I can't do my count. Where's my 0 line here? Okay, so this is 0, 1, 2, 3, 4, 5. So it is at 5. That doesn't make sense. So my center line, where this was cut in half, where I've got, so if this is center line here, I'm going 1, 2 down, and then 1, 2 up. Oh, I know, I did my count wrong. That's why. Okay, so my center line then, I'll do it in green here. This would be the line here that would cut this graph so that I had the same amount below in displacement as I do above. So this went 2 ticks, 2 values if you want to call it, and this went 2. Where I was making my mistake before is I was counting from 0 instead of counting from the line where it actually went. So it's covered a distance of 4. So my center line then has to be halfway in between there at 2. So that means my amplitude for this one, instead of, if I think of this as being my graph, instead of starting at, or just going up 1, I'm going up 2. So once I have identified my center line, I can tell that my amplitude is going to equal 2. Okay, so this graph went 1, 2, 3, 4 as a distance, so halfway through there means that my amplitude is at 2, and I can draw that center line then, or that vertical displacement line, 2 above, which would make it at 3. So period, when does this graph start to repeat itself? So if I take a look at this, the whole graph here, I don't have a repeat. If I started here, my repeat doesn't happen again till it reaches here. So that means that it has traveled the distance. If this is negative pi, this would, or negative half pi, this would be a negative pi and a pi to here. So it's gone 1 pi, 2 pi. So my period is equal to 2 pi. I think of this as being a cosine graph. Well, first I'm going to write this. So now that I have my amplitude and my period, if I think of my cos graph, cosine I know has to start above my axis, right? Above my horizontal axis. So that means for this graph here, I could say that my phase shift would have started here. Okay? So my cos graph phase shift would have been here because that's where it starts above. If this is my new origin, right here is the new origin for my cos graph, then that's where it would have started at. So my phase shift for this cos graph normally it should have started here at the 0, but it has now started here at negative pi. So that means it is a left pi. So from this so far, I have my, if my period is 2 pi, I know my center line is at 3. I figured out my amplitude is a 2. So that means my A is equal to 2. This completed one full cycle in 2 pi, so then that means that you could find what your B is. Because normally when we do our period is equal to, here, let me write it this way, that'll help. 2 pi over b. So if I'm solving for this, what I'm saying then is that 2 pi is equal to 2 pi over b. So by cross multiplication and solving here, my b is just equal to 1. So I know my a is equal to 2, my b is equal to 1. I have a phase shift left pi, so that is my h value. My k value then is, where did that line move? So it went from 0 to here at 3. So that means that my k value is the 3. So if I put that all together for a cos graph, I have y is equal to a value of 2 cos, my b value is equal to 1, so you can put it in there. You can go 1 times x. Now my phase shift, the h value was left pi, so that means it had to be a positive pi in here. And then my k value was, I went up 3, so it's a plus 3. So that's what it would, the equation would look like for a cos graph. If I want to do it for a sine graph then, Sine graph I know starts at 0. So I want to go take a look at this and see, okay, where is my 0? And you have a few choices where you can start at. But what we want to look at is where would it be at the 0 line and then starting and then going up, right? Because this is what we think of for a sine graph. It starts at 0, goes up, and then goes down. So this is what I'm looking for, is this. So this actually happens right here. What color should I pick? I'll do red. So if that's what I'm looking at, my 0 then, with the center line, would have been here. Okay, so sine graph, this is, I'm looking at the red dotted line there. So if I look here, I've gone from 0 up to 2, so I know that that's going to be the same. My phase shift, though, instead of starting here, I've started over here. So I've gone for my phase shift for that one, I've gone pi over 2 to the right. So then that means that my h is equal to pi over 2. Everything else then, my k value, instead of starting at 0, is starting at 3, so that's going to stay the same. My amplitude is also going to stay the same. My amplitude, I went from here up to, and then by the time I get back to repeating this, it's back over here, so it's still a period of 2 pi that it took to cover that. So then that means that when I put this all together, for my sine graph, I would have y is equal to, 2, because my amplitude is 2, sine, my b value is still 1, so whether you write that in there or not doesn't really matter, but it's going to be x minus pi over 2, and then my shift of 3. Okay, example 2. Going to work on the same types of things. So if I'm looking at a sine graph and a cos graph, I have to look at, okay, first of all, where is this graph cut in the middle? So I've gone a distance here of -4 up to 2, so that means it's traveled 6, so 3 would be my halfway in between here. So we had talked a little bit about it last time when you're looking for your amplitude. Your amplitude, I'm going to change my color, is always your maximum value minus your minimum, and then we divide that all by 2. So in this case, my maximum value was a 2, my minimum value was a -4, and if I divide that by 2, I have 2 plus 4 is 6, divided by 2 is 3. So if you have problems by looking at your graph and just counting to see what your center line or where your center line would be, then you can use this formula, your max minus min divided by 2. So then you can calculate from there your center line. Your center line, I'm just going to put a little line here so we're, center line, almost exactly the same formula, except instead of dividing, so this is where it's going to tell you what is that value of your center line. You're going, or instead of subtracting, you're going to take your maximum plus your minimum and divide it by 2. So in this case, my maximum was 2, my minimum was a -4. If I divide that by 2, -1. So that means -1 is where my center line is going to be. So I'll do my center line. I'll do it in the same colors as I did here. So center line now for this one, instead of being at 0, 0, says that it's now going to be at my -1. Okay? So now I take a look at this and figure out my period. So your period doesn't matter if you start from, okay, where do I go from my 0 back to my 0, or my maximum back to my maximum, or minimum to minimum. It doesn't matter as long as you're going from max to max, min to min, or 0 to 0. So if I look at 0 to 0, for this graph here, I started here, and then I don't go back to 0 till here. So I've covered the distance. This is pi over 2, pi over 2, so that's half a pi, another pi over 2, so that's 3 pi over 2, and another pi over 2, so that makes 1 full pi. Okay, or another way to look at it, if I went from my maximum value here to my maximum value here, that's a pi, or half pi and a half pi, so my period is 1 full pi. So if I look from max to max, so from maximum point to maximum point is a distance of 1 full pi. Okay, if I want to do the cos graph, okay, cos graph says I start up one value, or I start above the graph. So the easiest one to see is right here. At this point here is where I'm starting, or the first one, I guess, is where I started above. So that would mean that that would be my starting point. That's where my phase shift would have taken place. So I've moved over half a pi to the right. I already know my amplitude is a 3, so then I already know my A value for there. So the only other thing I need to figure out is, what is my B value? Okay, so from what I did here, I know that my period is equal to 2 pi over B. I said my period is a pi, so that means I have pi is equal to 2 pi over B. So B, I'm just running out of room here, B is equal to 2 pi over pi, so this is just a case of cross multiply and divide. So my B is equal to 2. So if I know my amplitude, just from here, my A is equal to 3, my B is equal to 2, my H I found out here was pi over 2 to the right, my K was from that center line, went down -1. So I can put that all together. So this graph that's my phase shift line. So if I put that all together, I have y is equal to, A was 3 cos, B was a 2. So 2 x minus pi over 2 minus 1. So the only thing I need to find out what the sign was is, where is my sign where I am starting at 0? So that one I could go right here. So that means that my phase shift then is from here to here. So I went from 0 to pi over 2, or sorry, pi over 4. I went a quarter of the distance. So for my sine graph, my phase shift was pi over 4 to the right. So that means my equation, everything else will be the same except for this h. So I would have y is equal to 3 sine 2 times x minus pi over 4 minus 1. Okay, and just kind of a summary for this so that you can put it all together, some kind of basic tips for you. So tips for finding equations. How about if I pick a nice purple? Amplitude, which is your A value, is always your maximum value minus your minimum divided by 2. Your center line, which is going to give you your K value, is equal to your maximum plus your minimum divided by 2. The period, easiest way to find that is just to count the distance from your max to max, or minimum to minimum. And it's okay to do the zeros, but you have to be careful that when you're doing your zeros, like in here, that you don't go, okay, I had a 0 from here to here, so that means for the sine graph, it's a distance of pi. So that's where you don't want to do your zeros, because your zeros are actually where it crosses it 3 times. So that wouldn't have been a distance of pi, that would be a distance of half a pi. Okay? And then your phase shift. To find your phase shift, mark your starting point for a normal sine or cos graph. And then just count, okay? So for this graph here, my normal starting point for a sine graph is 0, and that means that it has moved a pi over 2 distance. Normal starting graph for a cos graph has to be up at the 1, so, or up anyway, this because of the amplitude isn't 1, so that means that I went over a distance of half a pi. And then the last one is to find that B value, the horizontal stretch. Oops, again, a P. To find your B value, once you have your period, use your formula. Your period is equal to 2 pi over B, so that means your B is equal to 2 pi divided by your period. Okay, so those 5 key things are what's going to help you to find the equations for graphs.